Hi there, everybody. Welcome to Houdini Hangout. My name is Peter. Welcome to the stream here. Nice to have you with us. Hey, everybody. Hey, KM. Hey, Zach. How's it going? Good to have you guys here. Yeah, hopefully everybody's having a great day or night. You know, whatever time of day it is for you, or maybe it's tomorrow. Who knows? Hey, Mandy. How's it going? Welcome. Yeah, so... uh, this week we had a little special gift from Side Effects where the Houdini 22 Sneak Peek was released, which is pretty fun. I think it's always an exciting time of the year. Hey, Procedural, how's it going? I know back in the day when I was working in a studio and not kind of on the inside of things, I would always see this time of year as like Christmas, where it's like, what new things do I get to unwrap? So yeah, there's some fun stuff. We're gonna chat a little bit about the sneak peek. You know, I don't think there's gonna be anything too crazy that we can get into here. Hey dinosaurs. That's a great... Not dinosaurs allowed. That's great. I love it. Hey Athens, nice to have you here. Yeah, I don't think we're gonna get anything too deep with the sneak peek. I mean, it's just a quick preview. Hey Mo, how's it going? Hey Amon, welcome. Oh, no problem. Yeah, well, I don't know if these are so much tutorials. They're just stream of consciousness more than anything else. Yeah, hopefully they're helpful. Yeah, so I think the first thing to note here is that we're moving to Houdini 22 from 21. Hey, Raris, nice to have you here. So we're moving right on to 22 this time. We don't have any half releases or anything like that. So that's something that's a little bit different this time. I always wanted to move Houdini 22. Yep. So now we're just gonna skip right to whole numbers. That's kind of I think a little bit of a higher up decision, just to have these nice round numbers instead of all the 0.5s and things like that. Maybe in the distant future, if a 0.5 is needed, great. But for now, we're gonna switch over to the whole numbers, which is fun. But I think, yeah, I mean, I don't have a whole lot to say before we watch it. So if there's something that you're excited about in the chat, or excited about in the sneak peek, if you've already, I'm sure you've all watched it already. You know, put it in the chat. Let us know what you're excited about, or things that you're looking forward to. And I am going to, let's switch over to take a look at we'll play through the sneak peek, and then we can chat a little bit about it before we go any further here. So let's go over here. And I think what I'm going to do for now is just play this back and kind of let it go. Let's see here. We want more info. Well, we can only talk about the info that we have here, so that will be caveat number one. We'll not be sharing anything that's not here. So. Yeah, the music's cool, Mandy. I agree. It's good. It's good stuff. Bill Self does all of our editing, and he always picks great music. So. Yeah, Ammon, maybe next time they'll use your music. I don't know how he selects it. Do not know. Yeah, so if there's something that you're seeing here that you're like, oh, that's really cool, let's chat about that real quick. Drop it in the chat there, and we'll talk about it before we move on to other interesting things here. So, well, hopefully interesting. Can never promise. Is the UI updated slightly, like the parameter controls? I think you do see a little update to some of the things here. Everything is exciting. How are we supposed to pick? I love those little guys. They make me laugh. Athens, I'm not sure why you're zipping your mouth, but yeah, it was a good question. Totally fine. Ooh, that's an interesting question about the quad remesher. I haven't used Rhino really, and yeah, I haven't used Rhino. I'm not. I would have to say it. There's really, I would say at this point, still no way that it matches up, to the Exoside one. I mean, that one is really like kind of fully featured. So I would be really surprised. Let's see here. Where is that? Yeah. So I think this here is showing, basically it's showing that we're able to kind of keep these quite a bit stronger edges, basically, which was a real problem kind of with the last iteration of this. There was a lot of work that they did. Yeah, it was really difficult to keep. Hey, Philip, how's it going? Welcome. It was really hard to keep these hard edges, and that looks like they've made a lot of work in that regard here, as they've gone through this. So yeah, it looks like we're able to get a much stronger, much stronger results with that. Looks like there's also a rectangular method as well, or that's the rectangular method. Sorry. Yeah, it's supposed to really be a much more kind of complete iteration of it, right? I mean, I'm sure you'll see every remesher kind of feels like it's good at different things. I know different people use different things, depending on what the input geometry is a lot of times. But yeah, so yeah, the quad remesher I think is going to be really cool. It's definitely in a much stronger place now. Let me see what else everybody was Save my broken CAD. Yeah, exactly. Oh, I wish I had this. The number of terrible CAD files that I would get was just absurd. Yeah, let's see here. The rigging and relighting splats. Yeah, that is pretty crazy. I agree. So the splats stuff is all pretty cool. Like you can actually train. Like if you take a look at what's going on here, you're basically bringing in the Oh, cool. I'm sorry, Ammon. I'm not familiar with whatever. I'm glad to have you here. Apparently, other people you're getting getting some legend status here in the chat. So there you go. So with the G splats and stuff, it's pretty cool because like you're basically able to kind of convert your scenes into G-splat data from Karma. And they'll obviously get into like the actual like specifics of this a lot more, in the actual, in the actual release and everything like that. But there's certainly like a lot of tools here to help you kind of get to these finished results. And I think the results are really quite impressive when you take a look at that. It's like a G-splat there at the end, right? Because if you take a look at, that, where, sorry, I'm jumping around too much here. So if you take a look at this, this is actually the sublayer down here is a G-splat coming in because this is all happening obviously over in Solaris. And so, yeah, you can see all the lights baked in and everything like that. So that's pretty cool. And then, yeah, I think there was something, I want to say that this, like there was something like this that was like a little fly or something like that was like rigged and animated and as a G-splat. And so I think that kind of moved us in that direction a little bit more of like exploring this a little bit more with the doing some more animation with it and things like that. There's a lot of fun stuff here where you're obviously animating it. One thing I actually just noticed here is that it says at the bottom here, rig and animation by Henry Dean. Henry Dean is one of the people that helped create Apex. He's moved on from side effects, but that's pretty cool that he came back in to help out with some of that stuff there. So yeah, the G-splat stuff is really cool. I kind of thought Gaussian splats was like a little bit of like I don't know, it felt a little bit like everybody's freaking out about this and it's never really going to be useful when people first started talking about it, because it was like nerfs and G-splats and all these goofy things, and you're like, okay, everybody, let's calm down. It was just a few too many things, just kind of lingos just kind of coming out randomly. So but it's cool to see that it's actually pretty useful. I think a lot of people see it as something that can be like is really good proxy geometry, I would say, for like or for like background objects and things like that. If you need if you want maybe lighter weight stuff in the background, lots of stuff you can do there. So yeah, so Not Dinosaurs was saying, why go from H21 to 22? So why go from H21 to 22? I think because every release, like 20.5 was the Copernicus release, and like I think 19.5 was the Kinefx release, and it just kept feeling like every release was a big release. Like we try to make them pretty big, so it felt silly to like be kind of following this like arbitrary 0.5. I don't think there's any one thing that's like, oh, this is why we have to make it a full release. But I mean, certainly I could be wrong. There could be something that they talk about in the full in the keynote presentation where they're like, this is why we decided it. Like, I don't know that specifically, but I don't think there was anything specific there. Yeah, G-splats does seem like a nice alternative to photogrammetry. And it's cool because you can do it from 3D, right? You can't do photogrammetry from 3D, I guess. Like that's not really a thing, but like you can make a G-splat from a render, right? So that's kind of the cool thing that we're talking about. We're talking about here. Where was it? Here. With, this, obviously you've got this sphere of cameras that's going to train your G-splat basically, because it's a neural network type thing. So it has to it's a machine learning type setup. So you can see here, we're using Karma and Tops all together to like render this out from a bunch of different angles and then train the Gaussian splats on that. And just in case you're not familiar with what a Gaussian splat is, the reason it's called a Gaussian is because like, just like with Gaussian blur, it's kind of this like soft, blur type. And so basically what you're doing is you're doing point representations, but instead of individual points, you have these kind of, ellipsis kind of, shape. That's this like soft, like basically these soft little patches, and they all go together to make your kind of full image. And so that's what you're training, is where all these different Gaussians, or these little like elongated blurry like circles, basically where they go. And so that's what you're training when you're doing all of this stuff. So yeah, hey Fractaler, welcome. Viewer state rotation limits in Apex. Yeah, I'm actually not even sure what that is. Maybe you might be talking about these here, the keys, right? Maybe that's what you're talking about. I actually, to be honest, I follow like internally, I follow the the character stuff is so hard to follow because there's so much active development in it. But yeah, that's something certainly that there's hey there. Hi, Frivas, and who cares? And everybody, welcome. Oh, no, but don't apologize for being late. I was late to start the stream because I was in a meeting. So sorry, a Solaris meeting. So, yeah, I don't know a ton about this stuff. So I'm actually excited to learn a lot about the animation things because there's just so much active development there. It's kind of hard to keep up with it unless you really need to know about it. So I'm quite excited about that as well. I internally at work, I'm very kind of like always in Solaris. So to see the animation stuff will be very exciting to kind of get a glimpse at all that, what they've been working on there. Let's see, somebody else mentioned something. So Athens asked if the UI is updated, and I think you can see here that yes, the UI is definitely updated. A lot of different icons and things like that. It took me a while to get used to, I'll be honest. But yeah, and it basically, I think probably for this release you'll have a choice, is my guess, whether you want to use the old or the new one. But I've been using the new one a lot, and it's cool. It's different. It's like it feels different. So it's been taking me a little bit of time to get used to, but there's some really interesting things that you'll see when they do the presentation. There'll be some really cool things. And it's been a long time coming, I think, it's kind of a modernization of the user interface. So you'll see a lot of that one in the presentation, but I think you can visually see the differences here in this screen because there are quite a few. So it's cool. I think you'll all very, very much like it. Cool. What else were people talking about here? Hope I've been using the telescope. Man, I have not been using my telescope, unfortunately. Yeah, I wish I could, but life has kept me way too busy for that, unfortunately. This one was kind of really cool. You can see that this is another like machine learning training type thing here that's happening. This neural cellular automata. And it basically, you can train these different, these patterns basically, into a neural network, but, more or less. Yeah, a lot of people were also talking about, all the caustic stuff here, which I think is pretty cool too. So you can see here, we're getting a refraction from height. So obviously this is going to be, you can see with the little icon down there, that's a Copernicus thing. So this is going to be something that's going to exist in Copernicus. And then there's also this height from caustics. And I think it's actually a typo, if I'm not mistaken. I think it should be like height to caustics or something like that. But anyways, you can see here that, we're using the height to generate, we're using that to generate it. So yeah, it's very cool. There's lots of fun stuff here. And yeah, you can see here that you're getting some cool caustics from these lights and things like that. Yeah, I think that's generally the idea here, is that you're basically getting refraction based on your height map that you're putting in, right? So you're putting in some sort of height map, and it's able to figure out like, oh, okay, I would refract this background here from from the height map that's getting put in here. And then yeah, so I think that's pretty cool as well. So it's going to be, you can see here, it's obviously refracting that background image through this layer. And then there's other cases here where they're doing different stuff, like, light coming through and getting a refractive pattern here through this object. So there's all that kind of stuff that you can do as well. So, I think this will be a really cool demo. I don't think this is the whole thing being shown here, but, it'll be pretty neat. So, height effects caustics. Yeah, exactly. So Not Dinosaurs was saying maybe you can make splats from your renders, use them to populate background stuff. That's exactly what I would see as a good use for it. It's and you could instance that as well. It would be pretty lightweight. So, because it's just really a bunch of points with that information on it. Now, whatever renderer you'd be using would have to be able to support that. Karma XPU obviously does, but you'd have to have one that would be able to handle that, basically. So let me think, what else was in here that was, the metal thing. Yes. So what does that exactly say there? So this is an RBD material fracture metal. So this is an update to the RBD material fracture. So material fracture, obviously that node has traditionally done wood, glass, and concrete. And so metal will be a new material fracture piece of that, basically. And then in the next setting here, you can see that there's faster Voronoi fracturing with that same material fracture thing there. So there's obviously speed ups to the fracturing, because the material fracturing can take a while. So we're able to do a bit faster fracturing now. So that's obviously what's being talked about here. And so it'll be cool to see. I haven't actually seen that any details of that. So I'm excited to see what the speed improvements are. I have, obviously haven't done any like testing or whatever. So it'll be cool to see the details of like, oh, this is how fast it is compared to the previous version or whatever. Ammon, you're saying, is it faster than NPM for metal? I would say NPM isn't particularly fast for metal, because the harder something is, the slower NPM has to run, because it has to do more substeps. I think metal fracturing has always been something that you can do with RBD. It's just you have to set up the right constraints and all that stuff. So my guess is that there's probably a lot of kind of structure around how these things are being put together, so that you're able to do those simulations much quicker, because that's, I think that's was built into the car fracturing, the car like simulation stuff that we've added in. There was kind of some of that stuff built into there, where you're getting the crumpling and the metal crushing and stuff that's all being done through RBD. But now trying to bring that out from just being in a car specific thing and allowing it to be, metallic on a larger, kind of a larger structure, or a different structure than a car. Right. And with that in mind, I want to say that it's basically like on an impact, you basically move it, change from a glue constraint to a hard constraint. And then after a set amount of time, you basically like re-solidify that constraint. And so that is, that was something that I actually, if you go back and look at, like Stephen Nipping's stuff, like applied Houdini stuff, he shows a whole example of that, but it was always pretty hard to set up. I felt like it was always really finicky. So I'm hoping that this will give us some more guardrails to that, right? Yeah, so there's a whole rule set. Yeah, stiffness changes and things like that. Yeah, exactly. That was how you kind of had to do it all custom before. And now I'm hoping that there's a little bit more like, hey, you just turn this on and now it's going to kind of treat this as metal in RBD. So, yeah, I mean, granted, it's hard to know everything about how all of these things have worked historically, but that was always something that it was always a little tricky to do with RBD, but yeah, for sure. Let's see here. Anybody else bring up anything? Yeah, so I think the one thing that's pretty obvious here is that this is a little bit of a shorter sneak peek. We also don't have the crazy scroll at the end, which is interesting. I kind of like that it gives a little bit less for folks. And you'll see here we've got June 17th is going to be the release or the keynote presentation. I believe what is this? What is the? Yeah, okay. So I'm pretty sure that on the 18th, there will be a Hive in London. So if you're there, check that out. That should be there. Hold on, let me just look and see here. I don't know. Maybe it's not. Yeah, it doesn't actually say that, but I'm pretty sure that I saw it announced somewhere that there's going to be a Hive there. So, yeah. Anyways, there should be an event the next day in London somewhere if you're in the area. But, oh, the other thing I just noticed here, I didn't see this before. So here's the keynote. The keynote will be online on the 22nd. So on Monday. Monday after that, it'll be online. So that'll be great. Be able to watch it and see the keynote there. Yeah, the supersonic scroll in the end is very funny. Yeah, it is funny. I think it's nice to leave a little bit more to be experienced actually live. So one thing I'm really excited about is this here. So the USD in SOPs, you can see that there's a few things here that we're creating in this node network here. And you can see that we're basically setting this up in SOPs. We're in the geometry context. We can create our components kind of like, how the component builder works, right? You can see here we've got the component builder inputs and things like that. There's also this parent geometry node, which is a little bit different. So there's some cool stuff here that you're able to do in SOPs and actually see your USD structure building for you right there. So it's very cool. It allows you to output a whole bunch of things at once instead of having to like build a bunch of tiny elements and then assemble them all together in Solaris. So I think it's really, really cool. Is it like an instancing setup for USD and SOPs? It's not really about instancing. It's more from the standpoint of like, it's more from the standpoint of making assets than like big, huge, like instancing setups, right? So yeah, so it's a little bit more like that, right? You can see here, we're basically building individual assets, and yeah, you can set these up as different components in your scene, all that kind of stuff. You can see that we're building those here, and it's putting it into it's kind of putting it into our hierarchy for us there. So I think that's going to be really exciting, and I think it'll be cool to see how these work, because there's some cool features in here and some cool functionality that really isn't shown particularly here, which I think you'll find really cool. It's a neat way to work more in SOPs and have things happen with your assets. So it's really cool. And there was another thing that I was just noticing. Oh yeah. This too. This is cool. So, not that. The height field stuff. So you can see here, we've got now height fields are going to be using Copernicus, which is cool. And should make things nice and quick. because we're using all GPU calculations for them. But also you can do all sorts of Copernicus stuff on your height fields as well, because it's just a layer in Copernicus now. So so that'll be a really cool, I think, unification. And it's pretty obvious that we were gonna probably do that anyways, because, you know, layers in Copernicus are basically just 2D volumes, right? They're flat volumes, and that's the same thing that height fields have been in Houdini. They're basically just flat volumes. So yeah, so there was a little bit of stuff that had to be built into Copernicus to handle that. But you can see now that that's obviously going to be here, and a lot of really great like stuff that's been made, and like presets and different things like that. I think it showed some of those. Yeah, just different stuff here. Like I feel like there is a spot where it shows some of what presets exist. But yeah, really, really nice looking stuff. And obviously the tool set is really please an upgrade of UDIMs in Copernicus. Yeah, I haven't personally, I don't really use a ton of UDIM stuff because I'm not, you know, working in studios and doing really heavy stuff. But yeah, I would assume that there's going to be some stuff related to that. Yeah, there you go. There's some height field recipes. That's what I thought. There were some recipes that are going to be there to kind of poke around at and see how the new quote unquote workflow works, but it's very similar to the SOPs workflow. If you look at these nodes, you can see here that, you know, it's a lot of the same things, height field clips and different noises and things like that. But the cool thing now is that you have all of the noises that are in Copernicus that you could do for your height fields, which is pretty wild. Like, it gives you a lot more flexibility from that. So I think it's a really cool thing. Yeah, what else was in here that I thought was really neat? Yeah, cop supports in UE, which is cool. Yep, this is a interesting little demo here. Adjacency maps and time shift. I think that those are two cool things that if you know what adjacency maps are, it'll be a nice thing to have. I won't go too far into that because that isn't really overly explained here, but time shift, you can see we're using Copernicus here and time shift. So that I think is a nice little hint at some of the nice little quality of life things that are coming, that we're trying to make things a little bit easier to do things in Copernicus. So yeah, some cool little things there to pick up on if you maybe didn't before. Yeah, I don't really have much else to, like, you know, obviously I don't want to, like, yeah, I mean, you can see right here. I'm not telling you anything that doesn't say. Ripple solver with adjacency maps and time shift, and that's a Copernicus icon. So that's what that image tells me. So yes, for sure. I think that these are some of the nice, you know, quality of life things that have been needed in Copernicus. I mean, obviously it's this whole new context, so there's lots of stuff to kind of to build out. Yeah, it's a tough one to notice. You got to really pay attention to all that. There's lots of context clues. Yeah, so the adjacency maps will be really nice when you see how those work. It'll solve a really kind of fundamental problem that I was surprised exist. I was not on my toes, yeah. But the adjacency maps is really cool. And so you could make your own adjacency maps in Houdini 21. There's no reason you couldn't have, I don't think, but it's a much more robust thing in 22. So cool. Animate curves should be really cool. Underrated. Yes, true. Where did they show that in here? I didn't even, what demo is it? Where did they demo that? I don't even remember that. Is it here? No. Some magic effects. The red glass thingy. Come here, red glass thingy. No, it's not that. I missing it? Oh, here. Okay. Oh, yes. Yes. Curve animation. Yes. Yeah, that'll be really cool. Like it's crazy to me that like that didn't exist before. Like for some reason, I just didn't realize that didn't exist. But yeah, it's pretty cool. Like, I mean, it seems like a really basic thing, but it'll be a nice thing to have. Nice quality of life improvement. Yeah, you can see here. Obviously, that's a sweep. That's sweep. Revolve. Sorry, man, I haven't done a lot of like hard surface modeling stuff recently. But yeah, double flex. It does caustics. Yeah. But yeah, it's really cool. You can see, obviously, you're able to like keyframe your curves because obviously that's one kind of sweep that's or a revolve that's happening there, and then the curve is being animated. So yeah, it's really cool. I think the UI is really nice for it too. I think people will like that. But yeah, that's a cool one. I also this one is cool too. Like just, you know, nice. The next part of this here, the Material X flakes. They look really nice. Whoa, man, that one's quick. Yeah, it's cool. Got lots of different flakes options there. Yeah, nice for car paints and things like that. There's some good stuff there. And yeah, like all of these things are, you know, we're obviously keeping up with Material X improvements and things like that. So as you see, you know, if anybody's keeping up with Material X updates or USD updates, we try to follow along with those really closely. Yeah, we're as close as we can, right? There's obviously a cutoff date for when we can actually add new USD features, which is always a fun debate to hear people having internally, where it's like, like if they release one that's like in the middle of our like closer to the end of the development cycle, the developers would be like, should we include this? It's got some good stuff in it, but we got to make sure nothing's broken or anything like that. So yeah, it's an interesting process that seems like, I don't know anything about software development, even though I work at a software company. So it always feels like black magic to me. So, well, not the company Black Magic, it's dark magic. How about that? Just to be more clear. Next Mardini material saved. Yeah, exactly. There you go. You've got some nice materials going on now. So yeah, that'll be a good one. I think that'll be a nice material there. And I love this stuff. I feel like I just love these little characters. They're so funny to me. But I think that's also cool too. Like, you know, still updating some things with the motion mixer. Magic on rock material. Yeah, true. It is. We just have like these rocks that can handle electricity and do math for us. Who made the characters? The characters were made by I want to say, I don't know if I want to say it's like Sasha or Sasa Budimir. That S, I think it's Sasha Budimir, because if I'm remembering correctly, there was a goaltender in the NHL recently whose name was Dobesh, but it's only an S with the little curve on the top of it. So I think it's Sasha Budimir. So yeah, that's what it says at the bottom. So I don't think that's Tumblehead. No, I don't think they work with Tumblehead. Yeah, I'm familiar with the name. But yeah, he does cool stuff for sure. I just love it. It's so clever. I actually saw total tangent. I'm kind of I've always been like a roller coaster kind of theme park nerd, and there was the Rock and Roller Coaster at Disney. They just redid it to be Muppets themed instead of Aerosmith themed, which is really funny. But anyways, they have a animatronic character now of Scooter from the Muppets that in real life has one of these little like armatures here that you would use to animate a character, you know, like their hands and stuff like that. So they like motion captured somebody animating the puppet, like doing the puppetry, and then the actual like audio animatronic figure has that same thing. So it was really cool. It was really cool to see. So it kind of, this reminds me of that a little bit, like the little characters on their sticks. I don't know, something so charming about that they literally had to make an audio animatronic that had these little sticks with it. Side Effects is going to make me learn how to animate and dive into Apex. I'm getting really excited. Yeah, it is cool. I mean, I'm not an animator either, so I understand that. No, I will not be in London this year for the release. No, no need for me to be there. I will be going to SIGGRAPH this year though, so that will be my my event, one of my events that I'll be at this year. So yeah, but no, I wish. I love the UK. I would I hope they fix the issues of animation layers disappearing. I do not know about that, so I would assume that they are hard at work to make that not happen because that sounds really bad. All right, I think that'll be maybe where we end this part of it. I don't really know of anything else here that we want to chat about, but if you have something that you want to throw in the chat and we can talk about it real quick before we move on, happy to do so. But if not, we'll probably move on and get to some other stuff. And I will, yeah, look at that in a second. Oh. All right, cool. Okay. I don't think anybody put anything else in the chat. So I guess we'll say that's the end of this part here. Yeah, I think it'll be a really fun release. Lots of cool stuff, lots of interesting new technology, and I will certainly say that is not the list of features. There is more features than this. But I think the marketing team decided to go for a smaller sneak peek this year instead of, hey, here's a sneak peek of everything. So this year we've gone, I think they went a little bit, more reasonable on the release amount. What is my take on this AI era? I will get into that very briefly because I have talked about this many times. One exclusive from you. No, I'll get in big trouble. I do not do exclusives. I'm happy, and I have plenty to find out anyways. So what's my take on this AI era? If you've watched my channel at all, you've seen that I am not I'm not someone that's diving deep into AI stuff. I have a lot of personally, I have a lot of question marks about the legality of AI, and beyond that, I have a lot of questions and thoughts about the ethics, or the ethics of the whole thing. So I kind of take the legality, like, yes, like I think when everybody says ethical AI, they're talking about legal AI, things that can be legally defensible. Ethical AI, I think, is a different question that nobody really wants to actually talk about because business doesn't really care that much about ethics. It does a little bit, but not too much. But all that said, I think there are good uses for what we would consider quote unquote AI. I think if you watch the Houdini sneak peek here, you'll see quite a few quote unquote AI things, but they're not AI. They're machine learning. They're training. They're stuff that is what we would consider traditional AI. We're not diving into some generative AI thing. But for me, I find some of that stuff really, really interesting. And it's something I'm really excited to like finally be able to get behind, like something in this kind of current, like so much of it was like type your text in and you get this thing out. And I just find so little appealing about that. It just doesn't do anything for me, which is like, fair. If that does something for you, I'm not here to like criticize that. But for me, the thing I like is the journey to get there, right? Like for me, when I get close to the end, I have a really hard time finishing stuff because I really don't care about the very end part of it. Like some people really care about the pretty picture and pixels and all that stuff. And while I think that's great, I've always been really interested in the really difficult stuff in the middle. That's been the part that's my favorite to kind of mess with. So that's why you see this channel. I don't get to the end of things very often. So apologies on that. That's just never been my world. But I really like the stuff that's machine learning, stuff that's I think there can be AI models that that have been trained off of data sets that are reasonable, and I think you certainly can find some that would be like, yeah, I think this is a reasonable thing that's been trained on, and yeah, and you have a really cool outcome from it. Probably a lot of more education, like more research based stuff rather than stuff that's just trying to be some sort of commercial product basically. But anyways, that's my take on it. I think there's going to be cool. There's going to be stuff that's going to be good and bad about kind of where things are going. I don't think AI is going to take over the whole world. It's really still just a fancy autocomplete, and I'm not really that jazzed about it. So anyways, that's my take on it. Glad some of you agree. If not, that's fine too. I'm fine to be the old guy that goes and lives up in the shack in the woods. Like he's getting robots. He's getting See, that's the funny thing, is that these current ones, they're not thinking. That's the funny part. But anyways, all right. Yeah, it looks like maybe I'll be on the kill list for the robots now, but that's all right. They can come to my cabin in the woods, wherever that is, wherever I've fled to, and they can come find me there. No, I know, Zach. I'm just, I'm messing with you. I'll stay. Okay. Anyways, all of that said, let's jump in and do some actual Houdini stuff, because that's in the name of the stream. Okay, so there was a bunch of chat on I'll fight with you. Great. Wow, I've got a lot of people to help out. That's cool. At least I won't be alone in the Terminator scenarios. So everybody, there was a bunch of folks talking about like an effect like this, basically, where you've got particles coming up and forming, a shape and then blowing away like this, right? So I'll show you. There was if you want to go check out the Discord server. Oh yeah, I guess I should have mentioned that I have a Discord server. These are the streamer things that I always forget how to do and don't do them well. So I guess, like and subscribe and smash that bell button. I don't know. Somebody said I should say that more often. Oh my gosh, you've got an intruder. That's awesome, Mandy. Yeah, there's a Discord server for Houdini Hangout. If you'd like to join that, you go to houdinihangout.com. There's an invite link there. It'll let you into the Discord server and you can go there and chat. This topic came up on there and was like, hey, how do we do this, right? How do I make this this little effect here? So how do we make these particles coming up and then, obviously transitioning into some shape and then blowing away? So there's a few things, like when I see things like this, and granted, I'm just a guy that worked in an advertising studio, and, there's a lot of really, really smart people out there. So hats off to everybody that went on and gave help and stuff like that. I'll just give you what I would think about when I'm looking at this. So obviously you have to emit from some sort of like circular area here, or maybe like a ring of some type. Then we're going into a shape, and then we have to move, right? We have to blow these particles away. Now, whenever you're working in with particles, you're working with DOPs, right? I mean, technically, anytime you're doing a simulation, you're working with DOPs in Houdini. And if you want a really great, post or bit of information on that, check out Toadstorm's DOPs Isn't SOPs link. It's amazing. Go check it out. It's really, really good. It'll give you all of the best information you can imagine on that topic. But kind of the main idea here is that when you're in DOPS, it's really basically like taking data that you've given it at the beginning and doing something to it frame by frame, each frame applying some sort of new bit of information and moving your points around, your polygons around, whatever you're working on. So in this case, we're working with particles, which are just points. And so as we're moving them around in our scene, we have to think about the fact that these particles all came from this disk, right? That were sitting on the ground, and they've come up and formed this sphere. And there's really no way from the beginning of that to know this is where that particle is going to end up in this little sphere, because there's forces acting on it and all sorts of things like that. So with that in mind, we then have to, in order to make this kind of break apart, is coming from right to left in this case, we need to apply attributes into the simulation, like somewhere inside of the simulation, to be able to affect it based on where it currently sits at this frame, at a certain frame. So whenever I see something like that, that makes me think I need to do something with a SOP solver in POPs, right? Or in any particle or any simulation in Houdini. And that sounds scarier than it is. It's really just basically you're converting your current DOP geometry back into SOPs, doing something to it and bringing it back into DOPs again. So it's just an extra little layer of calculation that's happening in there. So it's not as scary as you might think. And if you are like a MOPS Plus subscriber or person, if you own that, you can actually do most of that kind of stuff where you're updating things in DOPS using the MOPS tools. You can do that. You can basically just have a little fall off thing that goes across it, and it just tells it, hey, now apply this new force here. So anyways, that's what we're going to do. That's kind of how I would look at this and think about it. So let's take that, and I'll just move this over here, and let's get started here. So I'm going to drop down the geometry, and let's get started here. So we'll just say here, yeah, Henry is the GOAT. He's awesome. Henry's super nice guy and super smart. So always good to have Henry around and putting his 2 cents in. Okay, so we'll just do, I'll just call this art directed pop sim, and let's color that up to purple, and let's dive inside. So for this, I'm just going to do a torus. You could also maybe do a circle. Can you do a circle though with it broken up? No, I don't think you can do a circle with a hole in the middle. Okay, we'll just do this. This will be easy enough. So I'm just going to do the stupidest thing I can and just transform this into a flat little plane thing like so. So we're just basically gonna get a little disc like that. I'm gonna make this a bit bigger. One of the things that I noticed, I was playing around with this when everybody was talking about this on the Discord, and one of the things I noticed was that it really was actually a lot easier to do this as like a bigger simulation. It just felt like the forces were a lot more controllable than just at this really small scale. So just kind of going up a little bit bigger than the kind of default meter scale is good. I felt was pretty good. It doesn't really matter. I'll just move this up by like, just move this up a little here. Maybe we'll move it up by the same, like 0.1. Yeah, we'll leave it at that. Cool. And then there's a few different things that we could do here. Okay, we'll have a few problems along the way here, so hopefully I'll be able to kind of talk through what some of these different things we're going to run into are here. So here's our pop net. This is going to now start emitting things into this. Probably don't want it to emit for too long. Let's see, how long does this emit for? Basically emits for like 3 seconds actually. Okay, we'll do it 3 seconds. That sounds good. So we'll have this thing emit for 3 seconds. So what we can do here is we can go over to birth. We can change our constant activation. This is our this is like a way to basically say, is this on or off, right? I don't think it can do fractional. Let me see. I can't remember if this can do fractional or not. Don't think. Yeah, I don't really know why this isn't an integer, but anyways, it is what it is. So what I'm going to do is I'm just going to put a little function in here. So I'll say $f. Actually, you know what? Let's just do $t since that's the actual seconds. And we'll say $t is less than 3. So this should activate when that comes back to be true. So we're going to activate until there when we get to 73. And now we've gone for 3 seconds basically, and we've got this emission. And how many? So I'm just going to do this to say pop like that. That makes sure that only the pop object is coming out. That's this pop object right here. So this is just basically giving wildcards around it and saying, hey, just whatever pop object that we have, give us that. So now we're getting these points out here. Let's just put down a null just to see exactly what's going on here. Great. Okay, so Houdini scares me. It's not that bad actually. You know, it's different than a lot of other softwares, and it is hard when you've learned other things, and this is like a new way of working. But we actually find that a lot of students, I work with a lot of like professors and students and stuff, and we find that the earlier that they get that in their, just are exposed to Houdini, not even like, oh, our whole program is Houdini, but like the earlier you're exposed to it, the much easier the learning process is. So it's very interesting that it's kind of more so the unlearning of other things than the learning of Houdini that's difficult. But anyways, okay, so we have this PopNet here. That's funny. Those are both the softwares I've used, Cinema 4D and Houdini. Okay, so we have these particles that are getting sourced here, right? They're just scattering onto this object. Very simple. We need to have something that these are going to get attracted to. So what I'm going to do is I'm going to grab my logo here somewhere. Let me see. Where is my logo? Sorry, I'm just going to grab it real quick here. Okay, there it is. Okay, this will most certainly break for other people, but learning Houdini is always fun, and it seems like it's an endless process. Yep. That's cool, Maitland. I didn't realize that. I like this. 4D scares me. Or I thought that I just read that with like 4D scares me, 3D scares me. Oh, that's funny. Anyways, let's do an attribute delete here because for whatever reason, Illustrator files come in with a black color on them. So we're just going to delete that. And your explanation makes it look easier though. Do I have paid courses? Nope, I do not have paid courses. I have courses on sideeffects.com. So no, I don't really do like tutorials in that sense, but I certainly do have tutorials that are on sideeffects.com. I've done a bunch of USD stuff though, so if you want easy stuff, that's not it. that's another learning process. Anyways, thank you though. I really appreciate that. It's very kind. All right, so let's do a poly extrude here. We want to make this a bit thicker. We could also use the labs extrude as well. They're both perfectly fine. Let's do that. Let's do a match size. That's going to allow us to be able to bring this kind of right into the center of our scene, so we don't have to worry about lining it up or anything like that. So now we've got that centered, and then we can do a transform. So in order to know where I'm placing this, I'm just going to hit my little template flag here and move it around so I can see where this is going to, maybe like so. And maybe we'll scale this up just a little, maybe like 1.5. I don't know. Sure. Something like that. I don't want to go too crazy. All right. There. Let's do that. 2.75. Great. Okay. So let's have this be our source, or go into the... I'm glad you've gotten some stuff figured out there, Mandy. Mandy had won, I think, one of the days for I don't even remember what all the things you won, but you won some stuff from Houdini, so congrats. Okay, so we've got this here. It's animating and doing its thing. What we want to do is have this attracted to this object, right? So let's come in here and let's start doing some work. So what I'm going to do is I'm going to do a pop attract. So we can use this attract to attract towards that position, basically. And what I'm going to do is I'm going to say, we can do, let's do points here. I'm actually not even sure what surface points does now that I'm thinking about this. So let's go in and check. So I'm kind of curious what surface points is. Points on the surface. Oh, I see. So you're setting it to the primitive in the UVW. Okay. No, we don't want to do that. We want to use points in this case. That should be what we use here, because particles is going to be different. We want to do points because, and we're going to use the second context option. And what we're going to do is we're going to do a point per particle. And what we can do then is we can match up where we want these points to kind of end up, right? And give them a goal position, a goal location to go to. You can see here that we have our particle ID and our goal ID. So these IDs need to match up, right? And right now I've just put into my second context geometry, it's just my whole logo. It's not actual points. So what you're going to see here is that these are going to sort of move around and let's see here. So let's do this at 5. Yeah, so these are all now trying to kind of go around one point, basically. So they're not actually like going towards their goal locations. And they're obviously shooting way past this. So let's also do a pop drag, just to throw that in there, just to kind of give us a little bit of drag forces here. There you go. So you're starting to see now that we're getting it sort of to be like matching up to this logo basically, but just randomly, like they're randomly going to locations here. So let's find a way to do this. So let's do a points from volume. So we're going to use this to basically set up a bunch of points for us that we want these points, our particles, to be attracted to. So let's go like, I don't know. That's probably not even enough. 55,000 particles. I don't know. Let's just kind of go around here. Yeah, that seems pretty good. And let's make sure we're jittering the scale of these. So let's just do that at 1. Hey, Karas. Welcome from Spain. Some of my friends were just in Spain a couple weeks ago. They might actually move there, but anyways. So I've been talking about Spain a lot. Very cool, though. Would love to go there someday. Cool. So, yeah, so we've got this. The other thing we could possibly do is kind of like, add some to the, Spain is amazing. I can imagine. I feel like the people there would be so nice, and just it'd be like it's probably just I don't know. I feel like it'd be like a party all the time. I don't know. It just seems like people are just super, super friendly. I mean, maybe I'm just feeding into cliches, but yeah, so we could do some, no auroras though. Yeah, that's true. All right, that looks pretty good. We've got a nice little density going on there. Okay, so we've got these. Let's do an enumerate here. If you're not familiar with this node, it basically adds an attribute to each of the points. In this case, I'm just going to add the ID. It's basically a really quick way to update each of your points, you know, position or your point number to be the ID, basically. Oh, cool. No, Not Dinosaurs is also from Spain. Cool. Very nice. Okay, so we've got this now, and we've got our number of points here. So what we could do, let's do this here. Let's say goal points, and this is out particle sim. Cool. Okay, so we've got these here, and these are going to start attracting to the logo, right? But some of our problem here is that, first of all, this is going way too fast. But some of our issue here is that our particles are just not like, they're basically not enough of them, right? So we need to figure out a way to basically make these enough particles here, right, so that they match up. So let's do that. So cool. Parties, people being outside and socializing, warmth and good food. That doesn't sound too bad. Sounds pretty cool. I also would love a reason to like be able to use some of the Spanish that I learned in school. That'd be fun. Control S. What? Fractaler, why would I ever do that? Why would I ever save? Why would I ever save? That's not fun. Dude, that's just giving into the man. The man wants you to save your files. I want to live on the edge and not ever save. Okay, there we go. Everybody good? Oh man, I am the just the worst. Does that mean a future Houdini Hangout in Spanish? God no. There is literally no way I could do that. I just wish I had a reason to like even use the tiniest little bit of tiniest bit of Spanish. I am do I use the incremental save option in the preferences? I don't do the save in the preferences because a lot of time there's a couple things. One, I get a lot of files from like people that are asking me to help with stuff, and if I have that on, inevitably it will save over the file that they've sent me, and I have to keep re-downloading it, which is obnoxious. So I don't do that. And yeah, the incremental save would be good, but then I don't know. I haven't been in production a lot. I've not done that, but if you're in production, yeah, you should have your save on. It's just a no-brainer. But for me, a lot of times it ends up causing me more trouble than it's worth. But anyways, let's get back to this. Okay, so we've got our goal points here, and basically what we want to do is set these up. Now, one thing I'm not sure is why these ones are not attracting. That is an interesting question to me. Okay, I can maybe sort of get the answer to this if I go to the end of this. Okay, how many points do we have here? We have 15,000. Yeah. So why are those not attracting? That's really strange. Let's see here. What am I doing? Okay, pop attract. Let's just give this a little bit more just to make sure we're not hitting some weird limit there. It actually could be the limit now that I'm thinking of it. Yes, 100% is, because that just happened to be 5 meters to that. So let's just say 7.5 is our max distance. Anyways, we've got these things all kind of coming up here. Great. So what we need to do is we need to basically say for our sourcing, this is the birth rate here, and this is how many per second. So what we could just do is take the number of points there and divide it by 3, basically the number of seconds that we're emitting this for. So we could just say, let's see here. Can we get the number of points? Yeah, I thought so. Number of points. Oops. And then from the node, it's going to be goal points. There we go. And there we go. So our goal points, 205,000, and we could just divide that by 3 because that is our emission per second. So now we should see that we get a much nicer bit of this here, and it should all kind of congregate into our little Houdini Hangout logo. Now there will actually be a couple of points here because it's hard to exactly do that calculation. So, also, it's probably -1 actually is what we need to calculate there now that I'm thinking of it. So if we do endpoints -1, maybe that's it. Maybe that's what I'm thinking of. Maybe that's why this is leaving a few extras. Let's just see how that works. No, there's still a few there. That's okay. Anyways, we can just do the endpoints. There's no reason to worry about that. I'll leave those extra parentheses just to annoy someone. Okay. So what we can do then is we can just do a pop kill, and we could just use that to just basically say, I think we could just probably hard code that if we wanted to. Sorry, I'm just thinking. Maybe that's not the best way of doing this. Let's just try this here. Let's just say like 10, subtract 10. Actually, we'll let all that math go and then subtract from it because that's not really doing the right math. Okay, let's do that. And then we'll do end minus. I think actually we could probably do -1. Let's just try that. Hey, there we go. That looks right. Okay, cool. Looks like we've got something going on there. All right, so we've got all those particles there. So let's do this. Let's do a pop. What is it? Axis? Yeah, pop axis force. So let's do that. Maybe we'll do that here in the chain. And so this, we're going to have it go straight up like that. And what this does basically gives you a couple different options. You can have orbit, lift, and suction. So orbit goes around the axis, lift goes in the direction of the axis, and then suction goes in towards the middle. So if we just hit play here, it's not going to do anything because it's missing that sphere. So we need to get that sphere to kind of engulf this. So let's go like that-ish. I'm just going to hit play here. I just want to see where this goes up to the top. Okay. I just wanted to get a visual of how high that is. Let's put it like something like that. That's pretty good. Okay. So now what we should start to see. Well, the other thing we could probably do here is could actually put the number of points down a little bit. We could maybe do it to like 2 or let's just do something a bit smaller here. Just to give ourselves a little less calculations that have to be done. Okay. So what I want it to do is I want it to suction out a bit more as it's coming up. I don't want it to go like straight to that. So what I can do here is I can adjust some of these things to kind of play with this. So let's see here. Cool. Okay. So let's change the orbit speed. Let's see 2. How does 2 look for the orbit speed? Yeah, it's something. All right, so let's do some suction. Maybe do 1 on the suction, and that's going to pull it inwards. Then it's going to go up. So this, hello, not dinosaurs. You're waving at me. So now we can have it suction inwards. In fact, I'm going to go a little bit harder with this because what we can actually do here is use these 2 forces to kind of pass it off to each other, right? Because right now, this attraction force is going up to a maximum distance of 7.5, and we don't really need it to go that far. We could have it probably be 2, and that would be okay. Because basically that would mean that if we took, let's see here, if we did this, and let's see, can we do a sphere around this? Just out of curiosity there. Okay. So what is the diameter of this right now? This is 1.5. So if we did a transform on this just to give ourselves a little, okay, like that. Just curious how big this is actually going to be. Size 2.14. All right. I think that's about 2.5. Yep, it's pretty close. All right, so let me just keep this on here. Oh, I can't. Okay, but that gives me an idea. Yeah, so that should be good. Maybe we'll do 2.25. That was just for reference. Don't really need that. Anyways, all right, so what this is going to do basically is it's going to pull in, it's going to pull the particles in, and then we can push them upwards, because right now they're just going to pull inwards and not do anything, right? So this is basically a way that we could hand off these 2 forces between each other. So that's going to pull in, then we can use our axis force here for our lift speed, and that's going to now push it upwards. So we can kind of use these all to balance it out. And that's obviously not working because we're not getting it into that sphere of influence. So this is basically just like a little, you know, I can kind of play around with this. I could maybe make the pop attract a little bit bigger. Maybe it's like 2.5. Maybe it's even 3. That's fine. But we can have this kind of come inwards like this. And then we can control how it kind of suctions into place then. And I'm going to just play with this a little bit more. I think I want the suction to be even a bit harder. So let's see here. Well, that's too hard. That's much too strong. All right, we're just going to play around with this a little bit, see what we can. And the other thing I'm going to do here is just give this a little bit more time. Maybe we'll do it to like 600. Because we want to have a little bit of time to let this thing kind of rest and chill. All right. So we have this coming up like so. just turn that suction down a little bit. Don't want it to go quite that strong into the... Just gonna play around with this a little bit, see if there's anything Cool. All right, that's kind of cool. It's a little different, but we're doing our own thing here just to kind of give it some interest. And what you could do as well, it's actually pretty easy to like kind of control how this this simulation, like how it's going to build these letters if you want it to be. Let me up this. I'm not sure if that's going to I'm trying to remember how exactly this is going to work, like how yeah, unfortunately there's a lot of overshoot here, so let me just try to make a little bit more drag here. Yeah, that seems to be a little nicer. Let's try like 1.5 on that. Okay, so now what we could actually do here is we could take these goal points. We can actually use a sort right here. And what we can do with this is we can actually sort these particles to be, you know, if you wanted to have them kind of build in some order. So what we could do is we could go to point group and we could do it by X. And this is going to sort the point numbers by X. And then the enumerate is going to do the same thing and enumerate by those point numbers. So now if we take a look at this, we should see that it'll sort of build from left to right. I mean, it's kind of a loose thing, but it should come together kind of from left to right. Looks like it's going from bottom to top as well, because those particles are it's interesting. It is going a bit like from left to right there. Let's just play around with it a little bit here. Sorry, I'm just trying to... Yeah, it's sort of going from left to right. I mean, it's hard because it's like the distance top to bottom is also a thing as well. But it's starting to do its thing. I think that's something. Cool. Now, the other thing we can do here is we could add in a pop wind. So I'm just going to throw this in here and I'll say, call this vortex wind, because I want to have some wind for the second part of it. And this will be, I'm just going to call this initial drag. I think we're going to want to turn that off maybe when we get to blow it away. But let's play around with this a little bit here. So we've got our vortex wind. I don't know. Just going to kind of play around with this a little bit, see what we can make happen here. Wiggly. So what we could do here is, well, first of all, it's probably a little too strong. I could just probably bring that down to be 1. Oops. Ooh. I think what we could do here is we could have our like calculate our distance basically. So we could certainly do that and have it figure out what the distance is between these two and use that like from our goal to our for our initial or our current position to the goal position. So why don't we do that? Why don't we do that up at the top here? We can do a pop wrangle up here, and it should be fairly simple to do this. If we take our input and use the second context geometry, that's going to be looking at this second input, which is our goal points. So what we can do is first we need to get our goal position, right? So what I'm going to do is make a vector goal, make this a little bigger so we can see this goal position. And we're going to say that's equal to, point. And this is going to be the first geometry coming in here. So 0 is the current input, 1 is the second input. So we're going to do 1, and then we're going to say the P position for the goal position. And then we're going to do at PT num, which is basically just the point number. So now we should have our goal position that we'll be looking at for each of these. What I could also do is just write this as an attribute if I wanted to see it. I'm going to go into our popnet here, go to our geometry, and I'm going to go type in goal pos like that. And there you go. We have our goal positions for each of these. So each point has its own goal position that it's trying to reach. So as these all start getting generated here and go blah, 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 emit, emit, emit. Cool. We should have all these different unique goal positions basically. And there you go. Tons of kind of sort them. See, they're all there and yep, great. Look good. The reason I can use ptnum here and not ID is because the ID is the same as the ptnum in this case. So it's kind of 6 of one, half dozen of the other. So if you did have like separate ID versus like if your point numbers didn't correspond to your ID, you'd have to look up the ID first based on the points ID that you're working on, because our particles here and our goal positions, those points each have their own IDs. Now they match up in this case, so it's not really a big problem. Anyways, so we've got our goal position. I'm just going to make this back into a attribute because I don't need to save that data. So we'll say vector goal position. And then what we can do here is just say f at, just call this dist for distance. And then we're going to say distance, and then we'll look at two different vectors here. So we've got our v at p, which is our current position, and we have our goal position, right? And so this will now write out our dist. So if I do dist here and go back to the beginning, we should have all of these updating distances, right? And what we can see is as it forms more and more into the logo, we're gonna have more and more that have very, very low distance here. We can see once we get down to this shape, basically the logo being fully formed, we can see the distances are really, really tiny. You're talking about tenths, hundreds, 10,000ths of a meter at the low end. Yeah. And looks like 0.03 at the other end. So we could pretty comfortably say that if it's within 0.1, we don't really need to have the wind affecting it. So now what we can do is we can come down to our vortex wind, and we can actually turn on, probably the easiest thing here to do would be to change the air resistance, because that's kind of overall the scale of what's happening here. So we can turn on the expression here, and air resistance is just air resist. That's the name of the parameter. So that's what we need to do. So all we need to do here is do air resist equals, because we're writing over that parameter. And what we could say is actually times equals, because we can multiply it by this. And we're going to multiply it by the distance value basically. But we can just do a fit, and we could say f at dist. So that's the current attribute distance that's existing on these individual particles. And so that's the attribute that we're going to fit. And we're going to go, let's just set this up right now just the way it normally is. It's like this. This is like kind of its default, right? And this is just basically saying map 0 to the attributes value from 0 to 1 to 0 to 1. So it's basically doing nothing. So what we want it to do is when it's at the really small end of it, we can set the value to be 0, right? And when we get to the high end of it, we'll multiply it by 1. So when it's past this distance, we're going to be basically the air resistance is on. And when it gets to 0, it's all the way off. So we just need to figure out what the incoming values for that we want to map. So the outgoing values we want 0 to 1. So here, we already said that on the close end, we can have it be 0 when it's 0.1. And then on the far end, you could probably have the air resistance still be pretty high when it's at like, let's say like 0.775. I don't know. Just kind of guessing here. But so that basically means when we get anywhere past 0.75, it'll be 1, and anywhere less than 0.1 will be 0. So let's just simulate this and see how that goes. It should make it so that this thing isn't jittering, like jiggling around when it settles into this position here. Sure enough, they're all nice and steady and stable. So now they're just they're jittering because they're moving, right? But they're not jittering because of the wind. They're not doing that weird wiggly thing. Oh, Wallaby, that's awesome. Glad you're getting in the home stretch on it. That's great. Good to hear. Okay, so we've got this kind of building into position. So that's great. And we've got this air resistance to kind of turn. Hey, Lindsay, welcome. Welcome. So we've got this air resistance here that's going to turn on or off this value. And so, So actually, I was just thinking about this, and I could probably do something. Okay. I'm just thinking about something here. So what I could do is do a pop stream here. Just gonna play around with this real quick. So what I'm gonna do here, all right, not dinosaurs. Thanks for being in the chat. Nice to have you. Okay, so I was playing around with this a little bit the other day because I was like, I don't use streams enough, so I'm gonna try to do this. Okay, so this pop wrangle is fine. We don't need to worry about that. That's good. Let's see. All of this, I think, could go here. And I'm pretty sure that this is how we would do this. And so what I'm going to... Let's just double check. I don't think anything should have changed here. Yeah, nothing has changed. Great. So what I'm going to say here is that we'll do the dissolve at frame, I don't know, 360 maybe. Yep. So what I'm going to say is we're just going to do a little vex here. If $F less than 360, then we're going to be in the in group. Just hit everything here. Hi, Leonard. Leonard, you're here? Say hello to everybody online. I know. You're so excited you've got your bone. Hi, buddy. Oh, there he is. Hi. Hello. Okay. How did you know that that's the camera? That's so funny. My wife is not home, so he's a little bummed. He's like, why is nobody with me? Oh, buddy. You gonna come hang out? Yeah. Okay. Anyway, sorry, little pup break there. Here. There we go. There he is. Get a little dog to cleanse the palate a little here. Some doggo. Okay, so I think that should work. And if I'm not mistaken, this should only work. So this stream will only be working up to frame 360. And I think after that, they're just going to start drifting away, I think. Let's see. Oh, you know what? I should have color in there too, but let's just wait a second. No. Okay, so let's try this. Wow, that's crazy. Maitland, that is a crazy story. A coyote walked by you? That's nuts. I saw a fox one time and I thought that was pretty crazy. A coyote's wild, man. That's... Like maybe dogs know what cameras are. Yeah. You know, I think animals are way smarter than we give them credit for. It's nuts. Like, I swear, like, dogs, I don't know. They're a lot smarter, I think, than we give them credit for. Oh, actually, sorry. It's got to be this way. If it's greater than 360, it's going to go into this and say, let's just see if this works. I feel like this should work, but I could be wrong. Let's just set this to red and then this one to green. He walked so he wouldn't get in the way. Oh, that's great. I love that. Like, oh, sorry, man. I don't want to mess with your shot here. Why is that not working? I thought that would have worked. Okay, well, for some reason I tried to do this the other day and it did work, but with something else, but that's fine. I'm apparently not being smart with the stream thing, so that's okay. We can do this way. It's not a problem. Okay, so let's do this back to the way it was. And what I'm going to do up here, let's see. We'll do a SOP solver. So this is going to be what we're going to use to kind of adjust the attributes for these, right? So what we can do is in our SOP solver here, we could just set up a little, I'm going to do the attribute adjust float because it has a nice little line function in it. And I'm just going to call this solve. So this is going to make an attribute called dissolve, and we're going to set this to be line. And I am going to set this end position, I think -1. Oh, sorry. Copy parameter, paste relative references, and I'm going to do the end position. I'm going to say, actually, let's try this, 0.5. Okay. So actually I can do this. Sorry, copy this, paste all relative reference positions. There we go. And then we'll just do -0.5 there. And now it should follow it around. Cool. Cool. Okay. So if we let this come up into the logo, I'll let this form up, and then I'll just kind of click to animate these basically. Okay. So let's just do this here, this around. Oops. Okay. So we'll animate the start position there, and maybe we'll just let it go to 480. Okay, cool. I'm going to move this to 360 though, just, oops. There we go. Okay. So one thing you got to be careful about here is that I have this dissolve attribute being set to add, and we want to say set always, not add, because within a solver, you can add and that value will stay, and then the next frame you can add, and then the next frame you can add, so you can keep doing that over and over and over again. So you don't want to do that. So here we're just going to make a little dissolve attribute that we're going to use. And that's basically a 0 to 1. So once it starts saying, once it's 1, then we know that that value, that's when we want the actual effect happening, right? So there we go, goes across, great, like so. Amazing. Okay, so we've got these attributes going. Now what we can do is we can add some effects for that. Oh, actually, that could have been a way to do the stream thing, but that's okay. No worries. So what we're going to do now is we can just add another pop wind that's going to, we'll just say dissolve wind like so. And what we can do with this is we can add some wind velocities along the X. So let's say maybe, I don't know, 3 meters a second or something like that. And so this should actually now affect it the whole time, right? So this is actually blowing it around basically and affecting it all the time. It's kind of interesting. It is still sort of working, but just because the force of that attractor is actually stronger than the wind. So that's kind of weird. But anyways, so we're fighting with a bunch of stuff there. But what we can do is we can use our Vexpression again. And this wind will only turn on when we have our F at dissolve. That's what we want to use, right? F at dissolve. And we want to do again the air resist. So F at dissolve, or we'll do times equals F at dissolve. That should be all we need to do, because the air resistance multiplied by this, it should start. Yep. And then the other thing we could do is we could just put a little time check in here as well. And we could just say, we'll just do a fit. Let's just add this into here. We'll do a fit and we'll say at frame. And so that'll be just the frame. And if we take, let's see, we'll just fit this to from 359 to 360. We'll say it's at 0 when it's 359 and 1 when it's at 360. And we'll just multiply this together as well, not add it. So that'll multiply together. So these are both basically like the dissolve attribute is being controlled. So if the dissolve is turned on, that's fine, but it has to be within this past this certain frame number 360 or else it's not going to turn on. So this basically, these are two checks that it's making. So let's see if that's going to work. Hopefully it will. So it should build up. Oops. Okay, so let's just make this way more. Just make it like 10 because it's definitely not, it's not letting it blow away. So we're just going to turn that up and see if we're going to see anything here. Not sure if we will or not, but could probably actually change that to be like Oh, thank you, Zach. Yes, that's probably what it is. Yes. Yes, I'm sure that's what the problem was. I definitely think I needed that. Just make sure I didn't forget to do that anywhere else. Don't think I did. Yep. I guarantee that that's what the issue is, actually. Probably was just fine with it for some reason, but it was just like erroring out. And was like, nope, I'm not going to tell you that you messed that up. Let's see. This is probably going to like shoot away at like 1,000,000 miles an hour. Oh, that's so bizarre looking. Okay. But I wanted it to go the other direction, so that's silly. Okay. Turn this off, go back into the SOP solver. This should be plus 0.5. I should actually just be able to, oops, that's the, yep, I should just be able to move these two keyframes. Yeah, so Maitland was saying the pop stream is cool. You kind of put a few particles and make them do something. Yeah, it's basically a way to be able to make your network kind of reflect a little bit more of like you grouping things into separate effects or separate sections. Basically, it's like giving different, it's basically an on-off switch between going into different areas. And actually, I don't really want that, so I guess it makes sense to not really do that in this case. But that's okay. But yeah, it's like basically a way to kind of section off different parts of your network that way. I'm actually going to go back in here and this over like that. Yeah, that's great. Okay, now we don't have to wait for as long for it to go. Thanks, Zach, for calling out the semicolon. Thank you. All right, so we have this wind here. Now the other thing we need to do is just kind of turn this stuff off, basically. Yeah, sorry, I was just thinking if there was a way to... I'm just trying to think if there's a good way to like disable a bunch of these things. So one good thing is this, the vortex doesn't really need to be adjusted. And in fact, probably the easiest way to do this would be to just keyframe our air resistance. Would honestly be the easiest way to do this. So I'm just going to keyframe this here because we can turn this off. At this point, don't need to worry about that at all. Oh, sorry. This was the vortex wind, which can be turned off as well. Then here's our axis force. We can do the same thing with this. Just turn off this air resistance as well. Cool. So both of those will be off now. And then we could also do that with our pop attract, I guess. We could just do that like... Just trying to think if there's a good way to do this. Yeah, let's try this. Let's just take this here and we'll go up to 360 and just go down to 0 on the force. Just see how that works. I'm not sure even what that's going to do without everything else, but let's just see. Not sure if that'll just like start drifting away or what, but yeah, it kind of starts to drift away a little bit. All right, I'm going to delete this channel. I don't want that. Let's try this. So force scale is just what it is. Force scale equals, and then, or we can do times equals let's see, f at dissolve. So that's going to be if the dissolve attribute is being added to this, it's going to turn it on or off, but we need to invert that because the dissolve is saying to do it then, and we need to not have that happen. Pop's masterclass. No, just trying to do the thing that we were playing around with in the chat. Hey Kieran, how's it going? So let's do fit, do the dissolve, and then let's fit that. Actually, we can do a fit 01 because that is 0 to 1. And we can just do the set 0 to be 1 and 1 to be 0. So we can just invert that. So it's 0 to 1 coming in, 1 to 0 going out. So that should work fine. Now the problem here is that I didn't put a semicolon there again. Like a dummy. Now the problem here is that one side of this is going to actually form and the other side won't. Nope. Just make me a liar. Just do it. Huh. Weird. I guess that's working. How is that working? Okay, I see what's happening. So the so what's actually happening here is that it is able to actually get all these particles to go. Some of these don't want to attract until they're past this spot in the x-axis. And so it's working. It's not super clean. What we could... No, Zach, that's not usually my problem. It's surprising me that it's working, but yes, that's very rarely my issue. Okay, so I'm gonna do a couple things here. One, I want this SOP solver to be a little bit smoother, so I'm gonna change the offset between these to 1. And so now, so you can see here, these are the particles that are not getting attracted, right, over here. But there's so few of them that it's really not causing a big problem. So it's kind of interesting. But there is like this weird little thing happening there, which I don't know what's going on there. But anyways, let's just see this go to the end here. And, oh, right. I actually have to turn that dissolve off. Yeah, it looks like a pixel effect. Yeah, it is weird. Just want to see... Nope, it's not that one. Okay, there we go. Now we have it fixed. Cool. Okay, so let's do this. Let's turn our wind back on. Let's change this to be 4. Let's set this amplitude to be 2 for the noise. And let's just see what happens here. Maybe it actually was better with it smaller. Let me just try this again. Oh, that's funky. Those got pushed over there. Oh, I know what's going on. I had this hard-coded in here at frame 360. And that's not when it should be. Shoot. 311 is when it should be. That's what it was. So let's say 310. 309. All right, let's go in here. I'm just going to take this one and just really, oops. How did I, okay. What am I doing here? The other thing I could possibly do here is I could put this over here. I think we could do it like this. Let me see. Oops. Not sure if this will work or not, but let's try it. Okay, that's setting those dissolve ones. Let's turn this. And now we're not getting any. Yes. Okay, perfect. And then what we can do is we can say, we're going to enable $F greater than, I don't know, 275. So this is basically just a little, this technically is all operating the same thing. It's just separate branches. So it's operating this first, then this, and then merging it together. So I think that's how that's working at least. Could be slightly wrong on that, but it's working. So that's great. Let's hit play here. See what happens. So right now the SOP solver is not even on. At frame 275, it's going to turn the SOP solver on. And then we start blowing it away. Whee! Cool. Okay. All right. And then, since we have this all set up sort of properly, if we change this back to like 0.2 to make a nice dense logo, this should now all update. Oops. Yeah, enable solver is it's a fun little one. It's kind of funky looking with the yeah, there we go. Looking good. Blow that simulation away. I forgot to up my cache, but that's okay. Cool. All right. We've got a fun little simulation there. Well, hopefully that was something a little educational for you all, even though it was just some particle work. But yeah, I don't know why I couldn't get those pop streams to work properly, but you know, it's okay. I was probably just doing something goofy. Great. Well, I think we're going to probably call that there because I think somebody that came in here and was asking for some help before is ready for dinner time. So I think we're going to call that, and he's going to get his dinner, and I'm going to call it a day for doing Houdini work. But yeah, very cool. Thank you so much, everybody, for being here. Yeah, Zach, you're very welcome. Thanks for joining as always. Yeah, I think we will call the stream there. So thanks everybody for joining. Thanks for chatting about H22. Lots of fun new things coming up in the future here. And somebody knocked my green screen back. Yeah, thank you everybody for joining. Keep an eye out for what we're going to be doing, you know, for times and if things are happening next week. I'll always put out messages and things like that if I'm going to be streaming. And yeah, thanks everybody for being here, for chatting, and we'll see you guys all next week. All right, everybody, have a good one. Talk to you later.